semantic processing. So how does a computer understand the meanings of words, right? So that's the question. How can a computer understand the meaning of an utterance, the whole sentence especially? So we have the magic machine, that is parse-tree. So it's a software that helps us know the exact meaning of a sentence. But sometimes a word is simple and it has one meaning, but we know that most of the words have more than one meaning, and they are used in different parts of speech, right? So let's take an example of spot, right? It's a small word, but let's see that how differently it is used in different sentences. For example, we found a nice spot for lunch. Here we know that the word spot is used for some place. We found a nice place for lunch. In second instance, out damn spot. So in this second example, obviously this spot is meant a stain, right? A blot, a stain. In third, would you like a spot of tea? It's a British use of the word spot. It means some tea, a little amount of tea. So in all these things, the meaning of the word spot is different. So when computer finds such a word in different meaning, how does it reach the exact meaning? So we have a program, word sense disambiguator. So this disambiguator disambiguates the meaning, right? So it tells us the exact meaning of the word. And what does it do? It uses context of the neighboring word. So it seeks help from the neighboring word, what comes before and what comes after. And also it seeks help from the other elements or in the document, from the whole of the document. So this is how it reaches the most nearest meaning of the word. So it uses rules that depends on context, and these rules can be driven by human intuition or by training a machine learning program. So we can make a program. So a word's syntactic and semantic properties are represented in the computer's digital lexicon. So every program has a lexicon, and the properties of the word syntactic and semantic, whether a word is a noun or adjective or adverb, or what is the meaning of what are the different meanings of a word. So they are found in that a digital lexicon. For example, let's take the word cook. We take it as a verb, though it can be used as a noun as well. So a verb's meaning, the meaning of the verb cook includes syntactic subcategorization, the syntactic element or arguments it combines with. So in the lexicon of the computer, the verb cook, the word cook as a verb, has all the subcategorization that includes the syntactic elements or its arguments. What comes after it, right? How many as a verb in traditional terminology, whether it takes one object, direct object, or it also takes direct and indirect object. So in semantic roles, here we have semantic roles for the verb cook. So we see in terms of the semantic roles. So thematic roles, the semantic role relations between a verb and its argument. Theme, obviously, you know that we discuss it in the semantic roles. Themes that comes after the verb in a sentence, right? And then other arguments. Other arguments include what comes after the predicate after the verb. That may have, in traditional term, object, direct object, and other adverbials, etc. So, for example, cook has a theme of a noun phrase. For example, Hussein cooked meatloaf. So meatloaf is a theme. It is, in traditional terms, just to make you understand, is an object. Cook, recipient, NP, theme, NP. So Hussein cooked Mary a great dinner. So in this sentence, obviously the recipient of the verb cook is Mary, and the theme is noun phrase, that is a great dinner. So we can also have another aspect, cook, theme, noun phrase plus recipient for prepositional phrase. So Hussein cooked a great dinner for Mary. Now the direct subject, direct object comes first, and then indirect object follows it, and it always comes with a preposition. So it has come with the recipient for. For here is a prepositional phrase. So computational semantics is largely concerned with representing these kinds of semantic function, the roles for assembling the semantics of larger phrases from smaller ones, right? So the program takes smaller phrases and then try to give us understanding for the larger phrases. So this is how a semantic processing takes place in the computer.